Hi, I'm Audrey Krenzer, and this is my ear model. So starting on the outermost part of the ear, we have the pinna, which is this whole portion right here. And the pinna's primary function is that it will collect sound from the surroundings, and it will help to localize or find the direction of where these sounds are coming from. It will also help to amplify sounds and protect the ear canal from foreign objects. And for speech, the pinna is important because while it collects sound, it will also process and enhance the auditory signals that are vital for recognizing speech sounds and comprehending these speech sounds. So the next structure is the helix, which is this outer edge right here, and the helix's primary function is to provide structural support for the pinna, and it will also funnel sound toward the concha, which will help to make for more efficient hearing and processing of sound. And for speech, the helix is important because it will help to, again, direct that sound towards the ear canal, which is vital for the auditory system to be able to receive that speech and then understand it for communication. Next structure we have is the concha, which is this divot right here, kind of towards the middle of the ear. And its primary function is to collect sound waves again and direct them towards the external auditory meatus. And it will also help to amplify the frequency of sounds, which helps us then localize the sounds and figure out where they're coming from. And for speech, the concha is important because it will again amplify that auditory information, so that will help to ensure speech signals are delivered with maximum clarity, and that just plays a big role in effective communication. Next is the tragus, which is this little piece sticking out right there, and its primary function is to reflect sound waves into the ear canal while blocking out any background noise and helping to shield the ear canal from the entry of foreign particles. And for speech, the tragus is important because it helps to contribute to that precise modification and delivery of sound waves, which then enhances speech perception and communication in everyday scenarios. So for the outer ear, we have these auricular muscles right here. And these muscles' primary function is to help protect the ear by assisting in reflexive responses like tightening during loud sounds. And they are more utilized by other species than by humans, but they still serve some function for humans. And for speech, they're important because they will again contribute to those small ear movements or the tensing of ears, which can help aid in spatial awareness of sounds in certain cases. So moving on from the pinna, we have the external auditory meatus. And the external auditory meatus's primary function is that it directs sound waves from the outer ear to the tympanic membrane and will amplify certain sound frequencies. And it also will protect the tympanic membrane and middle ear from debris, bacteria, and water. And for speech, the external auditory meatus is important because it helps to, again, amplify the sounds of speech frequency, which is crucial for understanding and processing spoken language. So at the end of the external auditory meatus is the tympanic membrane, which is right here. And the tympanic membrane's primary function is that it converts mechanical energy of the sound waves that enter the external auditory meatus to the ossicles. And the tympanic membrane will also act as a barrier to keep, again, foreign particles from entering the middle and inner ear. And for speech, the tympanic membrane is important because it transmits, again, speech-related sound waves to ensure clear and effective communication, and this will play a fundamental role in the understanding of spoken language. So getting a little closer look, this is the tympanic membrane, and coming off of the tympanic membrane is this muscle, the tensor tympani, and this muscle's primary function is that it will stiffen the tympanic membrane in response to loud noises, and it will also contract during things like chewing or swallowing to minimize the sounds we make and hear during these processes. And for speech, this muscle is important because it will help to, again, suppress those self-generated noises to ensure that we have clear, uninterrupted perception of external sounds, which is vital for understanding communication. So altogether, the function of the outer ear is that it is responsible for the amplification and localization of sounds, so helping us figure out where those sounds are coming from and understanding speech perception. And the outer ear will, again, enhance speech frequencies and focus sound into the auditory system. So moving into the middle ear right here, we have the ossicles, which are the malleus, incus, and the stapes. And these three bones' primary function is to transmit sound vibrations from the tympanic membrane to the oval window of the cochlea in the inner ear. And the ossicles will also amplify sound vibrations. So for speech, these bones are very important because they, again, are crucial for speech perception, and they will ensure that speech frequencies are transmitted clearly and efficiently. So connected to this stapes bone right here is this stapedius muscle, and this muscle's primary function is that it will dampen sound vibration to protect the inner ear from loud sounds, and it will overall just regulate the sound intensity of sound signals that reach the cochlea so the ossicles aren't pounding on the cochlea. And for speech, the stapedius is important because it helps to, again, maintain the clarity, intelligibility by reducing that impact of loud or damaging sounds, and this will allow for better, more effective communication. So looking at the biomechanics of the middle ear, they involve a highly organized system of structures and muscles that are designed to both convert sound waves into mechanical vibrations as well as amplify and transmitting them to the cochlea. And this process allows for the clear perception of speech sounds by improving sound intensity as well as protecting the inner ear from damage and ensuring that balance of pressure between all three of the parts of the ear. And these actions are essential for speech communication because they ensure that speech is not only audible but also intelligible in a wide variety of environments. So moving on to the inner ear, we have the cochlea, and the cochlea's primary function is that it is responsible for converting the mechanical sound vibrations from the ossicles into electrical signals and that detect frequency, pitch, and amplitude. And for speech, the cochlea is important because it detects and processes frequencies, intensities, and other aspects of sounds which are crucial for interpreting and understanding speech. So looking at the chemical transduction that occurs in the cochlea, the vibrations of the tympanic membrane and the ossicles will create waves in the fluid-filled cochlea, which causes tiny hair-like cells called stereocilia to bend and open special channels, which allows potassium and calcium ions to enter the hair cells, which depolarizes the cells and triggers a response. And this response is the release of glutamate to stimulate the auditory nerve fibers, which will then send sound signals to the brain where they will be interpreted as different sounds. So coming off the cochlea, we have both the auditory nerve and the facial nerve. So the facial nerve's primary function is that it will control facial expressions, control taste sensations on parts of the tongue, and it will also control automatic functions like tears and saliva production. And for speech, the facial nerve is important because it is responsible for the movement of the lips, facial muscles, and it is also essential for articulation, expression, and the emotional conveyance of words. And then the other nerve, the auditory nerve's primary function is that it will transmit auditory signals from the cochlea to the brain. It will enable perception of sound, and it also plays a role in balance. So for speech, the auditory nerve is important because it allows individuals to hear, process, and understand speech sounds, including pitch, volume, and intonation. So looking at the overall interpretation of auditory signals, we know that the sound will enter the ear and it will cause vibrations that are passed through the middle ear and then to the cochlea of the inner ear, where the vibrations are turned into electrical signals. And these electrical signals then take the auditory nerve to the brain, where the brain then will recognize the speech sounds and understand their meaning. And the brain will also use the context of the speech to help gain the broader meaning. And then when we speak, we hear ourselves, and the brain will use this feedback to adjust speech if needed to make it more clear or more accurate. So for my anatomical impairments, the first one I chose to look at was otosclerosis, which is an abnormal spongy bone growth that occurs usually around the stapes. And this will cause the bone to become fixed or immobile. And this fixed position prevents the stapes from vibrating effectively against the cochlea. So what this might look like in terms of physiological impairments is that since the sound waves cannot be transmitted effectively to the tympanic membrane, to the cochlea, this would lead to a reduction in the intensity of sound that is reaching the inner ear. And it could be a mild or more severe depending on how much growth has occurred around the stapes bone. And the second anatomical impairment I chose to look at was auditory neuropathy spectrum disorder. And this is when a sound will enter the ear normally, but the brain has difficulty processing it due to dysfunction in the auditory pathway. And this could be for a variety of reasons. It could involve issues with the inner ear, like the hair cells. It could also be the result of some kind of auditory nerve damage or the auditory processing centers in the brain. So the physiological impairments of this disorder would look like difficulties with speech understanding and speech discrimination, as well as difficulty with sound clarity. Even if it seems normal, there just might be some difficulty understanding what is being said. And here's just a closer view of my models. You can see all the different parts of it. Thank you so much for watching.